Okay, let's finish talking about multiplication. But now our expressions do not have radical symbols, they have rational exponents. And the rule is the rule. To multiply variables, you add exponents. The biggest mistake I see you guys make is you don't think. It says x to the 1/2 times x to the 3/4. If you look, I'm not asking you to multiply fractions. I'm not saying 1/2 times 3/4. If I wrote 1/2 times 3/4, then I'd be excited when you started singing, multiplying fractions is no problem, top times top, bottom times bottom. But I'm not asking you to do that. I'm asking you to multiply the letter x times the letter x. And the rule is to multiply variables, you add your exponents. So what I really want to do is I want to add 1/2 to 3/4. Now, here's the problem. Can you add those fractions right now? No, because to add you need a common denominator. We need our LCD. So what is the LCD of 2 and 4, everybody? That's right, it's 4. So now we're going to have to change the denominators to 4. And the rule said, adding fractions easy as can be. All you need is an LCD. If you change the denominator, you must change the numerator. So everybody look, I changed a 2 into a 4 by multiplying by 2. So that means I changed the numerator. 1 times 2 is going to be 2. This denominator stayed the same. It did not change. So the numerator stays the same. Now to add, we write the bottom, collect the top, reduce the fraction, then we stop. So now if we add 2/4 plus 3/4 is 5/4. Can you reduce 5/4? No. 5 and 4 do not have a common factor other than 1. That would be your final answer. Now you have to be careful. How do they want us to write the final answer? They could ask for 2 ways. They could ask the answer to be with a rational exponent, or they can ask for the answer to be in radical form. So it's all about the vocabulary words. We know rational means fraction. So if they say write the answer with a rational exponent, it means write the answer that has a fraction as the exponent. Well, we got that. So this answer would be x to the 5/4 if it's written with a rational exponent. But if it says write it in radical form, then this is not acceptable. Radical form means to rewrite it as a root. And we've learned anytime a variable has an exponent that's a fraction, you can rewrite this expression as a root. The root is the 4th root because it's the denominator, and the exponent is still going to be 5 on the letter x. Now here's the problem with writing a term in radical form. If it's written with a root, then a root has to be simplified. What root is this, guys? The 4th root. 4th root means you multiply the same term 4 times. Well, guys, can we simplify the 4th root of x to the 5th? How many 4s, groups of 4 in 5? So think about this. We know how to do this. We know when we're doing roots with variables, we divide the we divide the exponents. So the exponent's 5, and we're going to divide it by 4. How many 4s go into 5? That'd be 1 with 1 left over. So this is the problem with radical form. If you write your answer in radical form, then it has to be simplified. So if you wrote the 4th root of x to the 5th, it's not simplified. And again, let me explain why. X to the 5th means there's 5 x's connected by multiplication. The 4th root means you need a group of 4. Well, there it is. There's one group of 4, that's the x that came out, and there's one guy that doesn't have a group, he stays inside. You'll find out in higher math we'd rather leave our answer with a rational exponent, therefore we don't have to simplify. Let's try one more. I have the expression y to the 4/3 times y to the -1/3. Again, we're multiplying letters, y's. The rule is add the exponents. Now this is great because our exponents already have a common denominator, which is 3. So what we're going to add is 4/3 plus a -1/3, which we know would be 3/3. But can you leave your exponent as 3/3? No, because 3 over 3 is really 1. Can you write your exponent as 1? No, we've talked about that a long time ago. It's understood if you write a variable that if the exponent's 1 and you do not write it. So the product of y to the 4/3 times y to the negative 1/3 is just good old y. And that completes multiplication. See you for division.